This is a discussion of the so-called general two-stage model of equity valuation, which refers to situations where there is a short-term period of high growth in dividends, followed by an abrupt switch to a perpetual long-term period of lower growth. In this case, the short-term period of high growth is for 5 years, top right-hand side, and that higher growth rate is 10%. The S there stands for growth rate in the short term. That is followed by an abrupt switch after year 5 to a long-term growth rate of 4% in perpetuity. And the timeline looks the way it does. I've set it out to show that we have 1, 2, 3, 4, 5 periods of growth at 10% per annum, and that is immediately switches down to the lower perpetual long-term rate of 4% per annum. So we have a sense of a break in the growth rate at the T5 point on the timeline. We could deal with this situation by using the official equation for the general two-stage equity valuation situation. And that is a scary and daunting looking equation. It is, however, merely once you break it down and think it through in terms of what are the components of this particular equation, it turns out that it is merely an application of standard time value of money principles. Let me show you what I mean by that. The way I've dealt with this was to start with the information that we have, which of course is the required rate of return at 12%, those growth rates I mentioned a moment ago. And then in this situation, we are given the previous year's dividend, D0, in other words, at 25. And it becomes simply a proposition of mechanistically mapping out with your calculator, using the growth rate information that you have, what each of the projected dividends are going to be for the next 5 to 7 years. And growing that at 10%, that 25 starting point by 10% gets you to that, 10% higher, and all the way down to 40.26 at T5, which is the last of the high growth rate dividends. That then switches instantaneously down to a 4% lower perpetual growth rate, which means that the T6 dividend is only 4% higher than the T5 and the T7 and so on and so on. So what we have is a timeline with numbers against each of the time notches, and we also have, using our knowledge of how to value a growing perpetuity, we have a perpetuity starting at T5 with that particular dividend number, which then grows at 4% per annum in perpetuity. And we know that if we have a perpetuity starting at T5, we would then be able to value it at T4 with reference to the T+1, in this case the dividend at T5, divided by the required rate of return, which, by the way, is constant throughout the situation. It remains at 12% throughout, and the long-term growth rate of 0.4 gives us a value at T4 of that perpetuity of 503 Rand and 25. Now, that value, fair enough, is at T4. We're comfortable with that, but it just so happens to be the case that there is another cash flow that belongs to the owner of this particular equity instrument, and that is that D4 is 36.6. And we know from cash flow additivity that we are absolutely comfortable about the idea that we can add together the D4 number of 36.6 to the V4 number, which is a calculation of the value at T4 of that perpetuity. That doesn't matter because we know from cash flow additivity that the 503.25 is absolutely valid for adding to the 36.6 to determine an additive total at T4, which includes a a terminal value for the perpetuity plus the dividend that is going to be projected to be received at that stage of 539.84. Now that is a T4. We need the value at T0, and it becomes a simple proposition of determining using standard time value of money principles the present value of that T4 number, and we determine that that component of the value of this particular equity instrument is 343.08. But of course that's not all, because at T3 there's a dividend, at T2 there's a dividend, at T1 there's a dividend, and each of those add value to the equity instrument at T0. And it really just boils down to the idea that you, having taken the present values of each of those cash flows at T1, T2, T3, and then the slightly more complex cash flow situation at T4, the present values, add them together, and you end up with exactly the same value that you would get from applying the very scary looking official equation for the general two-stage model. And I hope you found that informative and interesting. I would just leave you with a final thought of watch out for that D0 number. I know as an educator of many years standing of this kind of situation that it's a very common error for students to inadvertently add the D0 number to the value at time zero. That is not relevant to the valuation. If you'd like to think of the D0 numbers being last year's dividend or a dividend received, stylistically you could say a moment before midnight, therefore it doesn't belong to me on T0 because it happened at just before midnight the day before. It belongs to the other shareholder, not to me. That might help you as well. Just to bear in mind that the D0 number, although it starts the chain of calculation of what the future dividends are, it is not relevant to the calculation. Try and avoid making that mistake. So D0, yes, it may be useful, but it doesn't form part of the valuation. And if you try plugging in, just mechanistically plugging in the numbers from the various inputs here, you will confirm that in fact that is indeed what the equation would give you. Now, this may not look any easier. It may look just as horribly complicated. But to me, this simply is, although tedious to an extent, it just boils down to two simplistic propositions from basic TVM being the valuation of a perpetuity, cash flow additivity. I'm now adding a third proposition, along with a series of L-shaped arrows, each of which just simplistically takes the present value of each of those individual cash flows. And that is it. Thank you for watching.